Hello, my name is Ondrej Mirtes and I'm from Prague, Czech Republic. Thank you for coming to my talk despite the title, which I admit is kind of mysterious, but the presentation could also be called How to Get the Most out of phpstan. So who uses phpstan? Wow, or at least heard about it? Okay, same people. And to explain to the rest what it does, I would like to start by talking about the difference between compiled and interpreted programming languages. So the compiled languages need to know about type of every variable before the program runs. They won't let you run the program with an error like an undefined variable or calling an unknown method or some other obvious error like that. The compiler in a compiled language acts as a first line of defense before you are even able to launch your application. On the other hand, PHP is interpreted. If you make a mistake, the program will crash when you run the line of code with the mistake. So, for example, if you have some kind of error hidden in the third step of your checkout process, you will find out about it, or your users will find about it when they click to your checkout process through third step. And you will have to test it manually, or you have to write automatic tests to detect it. So PHP developers, because PHP is interpreted and doesn't have a compiler, spend a lot of time uncovering mistakes that wouldn't even compile in our languages. So that's where a static analyzer like phpstan comes into play and saves you, because it analyzes code without running it. It gathers data about the code and makes use of type hints and PHP docs, and tries a lot to understand the code really well. And once it has data about the code and it understands it, it can spot out errors like calling an undefined function, passing not enough parameters to a function, and a lot more errors like that. And some situations are really easy to spot, and other ones are a little bit more tricky. So you might not know that, but PHP, if you reference an undefined class in situations like this, PHP stays silent. So some tricky errors are not even crashing ones, but they fail silently. So it means that instance of some undefined class, some undefined type will just be skipped. If you are catching some undefined exception, the catch block will be skipped. PHP will happily create a name to a class that doesn't exist. And if you have a type hint in a function that doesn't exist, the function will not let pass any argument to it. And that's how PHP behaves. So what's helping static analyzer a lot is a type system. So what is a type system? There's a really long article on Wikipedia about it. But if I can summarize it, type system answers you if parts of a program are connected in a consistent way. In other words, does an application work from the type's point of view? So for example, this is an example of a broken type system. So if a method is returning an incorrect type, then rather than the one that it's promised, it's a mistake, it's an error. And it breaks the problem. It breaks the program. So this can be verified statically. This can be verified just by looking at the code in an automatic way if you document your types really dutifully, really well. Another possible error is passing a wrong type somewhere. It's not accepted. So if we accept a string and we pass an integer, that's an error. Or if we are calling undefined methods on types, that's also an obvious error. But actually, this one is already a little bit tricky, because classes can implement magic underscore call methods. So this means that even if the method is not defined, but the class defines underscore call method. There are, I would call them virtual or magic methods, are created on the fly, and this can also be solved with the static analyzer if you tell it whether which methods are created in this special way with some kind of an extension. So you have to define rules what kind of method exists on a class like this. Another error in a type system is that when you assign a wrong type to a property. Unfortunately, properties cannot be type hinted natively, but static analyzers also interpret PHP docs for both properties and functions. So another possible error is that you are accessing a private property from outside of the class, or that you are accessing undefined constants, or that you are accessing array offsets when they are not accepted or supported. Like if you are accessing array offset on a class that does not implement interface array access, then that's also an error. Another possible error that's also not crashing, but represents a mistake, are impossible comparisons using instance of or three equals signs, or using a function like is_int, etc. So this if condition can never be executed unless bar is a parent of foo. In that case, the condition is always executed, and it's also not required to write it like this. You can just execute the code inside the condition. And there's a lot of more and more errors like this that static analyzer can detect for you. So for example, if you write an anonymous function, a closure, and you use some variable and you don't use that variable inside the closure, then you don't have to write the use for the variable. Or if you have some unused constructor parameters, you can also remove them. And phpstan also validates PHP docs for you so that you can be sure that you are using the right syntax and that the PHP doc is compatible with the native type hint. Okay, so who writes tests? Most of you. And who runs them in continuous integration server? Okay. I would really recommend that, because if you write tests and you don't run them periodically, ideally on every commit, then you don't have to write those tests, because if you write tests and you don't run them, then you will realize after a month that those tests are failing and they are completely useless. So my point is that phpstan is looking for bugs for you, but so do tests, and there's some intersection. So some bugs can be found by both tests and by phpstan. So why we are spending this duplicate effort when there's some overlap? If phpstan can find the same bugs as test find, so why are we writing all those tests? Because tests have to be written, tests have to be maintained, and they are expensive, and let's admit it, they are sometimes boring. So who likes writing tests for setters and getters? Okay, two people, and not anyone else. And I would like to tell you today that you don't have to write tests for every piece of code. Of course, you have to write tests, but only in places where static analyzer cannot help you. So I would like to show you today how to save time, and also maybe when you are already spending time on tests, how to write beautiful and maintainable tests with the right architecture. Okay, so static analysis is free. Computer does it for you for free, without any effort. But tests are not free, so our goal is to remove the duplicate effort. To write tests for code where phpstan cannot help us, and not to write tests for code that phpstan can reason about. And while we are doing it, we can help phpstan to understand the code better and to find more bugs so we can write even less tests. Because code understood better by static analyzer is also understood by developers better. So these efforts that I will show you will also result in much safer and readable code. So you are not just doing it for the sake of static analysis, but also for yourself and for your team. So I'm not saying that you don't need tests at all, because I didn't remove the orange circle, but you will focus your efforts in places where they can do most. So it might be a little bit controversial, but my opinion is that you don't need 100% code coverage, because it's very expensive and it's wasteful. Okay, so now for the tips. This session can be divided into parts. First, I will show you some local tips for your code that you can apply on a small scale in specific places in the code. And later, I will talk about application structure with some more wide-reaching consequences for your architecture. So first, I would like to recommend you to turn on logging notices. Who already logs notices in their code? Not a lot of, oh, well, about a fourth of you. And because notices are usually the most severe errors. Notices represent undefined variables. Notices represent unknown array keys or unknown constants. So when you turn on notices, you will find a lot of bugs in your code, and it's important to fix them. And this is also connected to defensive programming, because defensive programming, in my eyes, means that you should let your application crash on a first unexpected error. So you shouldn't try to recover from some unexpected state, from some weird state, because recovering from it increases the number of possible combinations your application can be in. And there's more stuff that can go wrong. So you should probably separate your errors into two groups. One is expected. So anything that the user can click through in your application, that's expected. So for example, if they are adding some item to a checkout process and the item is sold out, that's an expected error that you should recover from and show the user an error message. But if your database is disconnected, then that's an unexpected error, and you don't have to handle that in all of your places of your code. You should just crash and fix your database, and the user will have to survive with a general 500 error like that, because otherwise there's a lot of combinations that you can test, and it's not possible to test them all. So it's more likely that something goes wrong if you are not programming defensively. Okay, so what version of PHP do you have? Who is on 5? Okay, who is on 7.0, 7.1, and 7.2, and PHP 8? So I would really try to encourage you to use a newer PHP version, because you can write your code in a nicer way, it's safer code, and you also gain improved performance. So those who are on PHP 5.6, you can't write scalar type hints. You can type hint only objects and arrays. And that can be compensated with PHP doc, but PHP docs don't mean anything for the language runtime. But at least tools like IDEs and static analyzers, read them and use them. But if you upgrade to PHP 7, PHP 7.0 started to allow scalar type hints and also return type hints. So I encourage you to write them, because then you can rely on the types that you have in your code. But PHP 7.0 didn't support nullable type hints. Well, it supports them in a way so that you can always write string, name of the parameter, and then equals null. But that makes the parameter not only nullable, but also optional. So that it means that if you have, for example, a person object and you want to have a nullable name, it means that the setter, set name, can be called without any parameter at all. So it's just set name and parentheses, which doesn't make any sense. You want to either call set name with the name or set name with null, but not set name without any parameters. So there's actually no nice way in PHP 7.0 to have nullable type hints. And if you want to write a nullable return type hint, you're completely out of luck and you have to resort back to PHP doc. So who uses strict type hints that were also introduced in PHP 7.0? So strict types make you aware what types are traveling throughout your application. With strict types, you can't pass a string somewhere, an integer is accepted, and just hope it will work because it probably won't be. And each type is accepted only when it's type hinted, so you can pass string to string, integer to integer, float to float. There's only one exception. Integer can be passed to float because it's lossless conversion, you don't lose anything. But the other way you are losing stuff, so it's not allowed. And turning on strict types in your codebase has a really similar effect to turning on notices for the first time, because it will find a lot of bugs for you. When we first turned it on, we found a lot of code that didn't make sense at all, and tests that didn't test anything. So I really recommend turning it on because it's also much safer for your application. And ideally, you would use a coding standard, probably something for PHP CS Fixer or PHP Code Sniffer, that will make you put strict types on top of every file. And if you are starting with them, I recommend you to do it gradually, not to do it everywhere at once. If you have a larger code base, because it will really find a lot of errors for you. So you probably don't want to put it everywhere, just push it to production and see thousands of errors. You want to do it probably per namespace or per directory or something like that, and turn it really slowly and fix all those errors it finds for you. Okay, PHP 7.1. PHP 7.1 introduced nullable type hints. So now finally, nullable and optional are two different things. And so you cannot call this method with the parameter omitted. That's invalid. Okay, so who is familiar with the term stringly typed code? It's a pun for strongly typed code, and it means that everything is a primitive type. It's either a string or an integer. So this is better than no type hints at all, because you at least can't pass nulls in those parameters, but you can go a lot further with this, because by using primitive types like integers and strings, you're not communicating much information. So when you are using a string type hint somewhere, you should always think about the consequences and if all possible values are fine. So if we are type hinting string name, does it mean that we allow an empty string? Does it mean that we allow non-ASCII strings? Does it mean that we allow emojis? So that's everything. When you use a primitive type like string, you are really widening yourself to a lot of possible inputs, and you probably are not counting on every of them. And you're not realizing what you are allowing to be passed through your application. With integers, the same thing. Are you thinking about all integers or only positive ones? Is it if you type hint, for example, float price or integer price or something like that, do you want to allow a negative price? Not mentioning that you should probably use some kind of object for money, but that was just an example. And or if you want to accept, for example, hours in day, that means from 0 to 23, you should probably also don't use integer for that, etc. So trimming down possible inputs really reduces undefined behavior. So you should use objects as most as possible in your application. So what do you gain by passing an object somewhere? First, the object must be consistent and validated. So that means that if you are relying on an email, the email object should contain a valid email. That's a big improvement from a string, because if you type hint a string and you are meaning an email, the user can pass a lot of invalid data there. But if you validate your email in the email object constructor, then you are safe and you can rely on the email address. Next, the type hints communicate what can be passed to a function. So the developer doesn't have to guess what you mean by some parameter called ABC, but he actually knows what can be passed there and is verifiable by static analysis. And finally, the object methods that are available on the past objects are telling me what can I do with object. And you shouldn't just type in the parameters, but also the return types as well. Okay, so one code smell I see from time to time, because it's really easy to do this using some form libraries, is to type hint an array. But this really isn't very good, because with proper type hints, you shouldn't be able to call a method in a wrong way. But with an array type hint used like this, you can be sure that there are all the keys that you want to accept, and you are also not communicating what kind of keys should the array contain before passed to your function. And you also don't know the types of the keys inside the array. So this is not very analyzable and readable code. But one situation where array is fine is when you are passing an array as a list of values that you just intend to use in a for each or something. And it's fine if you specify what kind of values it contains. And unfortunately, right now, there's no better way in PHP for this. You have to use phpdoc. There's some kind of a hack with variadic argument, but that's limited, that you can use some type int, ... and number and name of an argument, but that's very limited. You can do it only for a single argument in a function, and that argument must be last. So I'm against that because it limits the design of our application.
And it explodes it.
Sorry?
It explodes it. If you have an object with three properties,
Yeah.
it inserts it as three arguments.
Mm-hmm.
So it doesn't really help.
Yeah. Okay. Another thing I would like to discourage is to write methods that accept multiple different types, because it might seem cool to accept anything and just deal with it on behalf of the user, but there are problems. Method which accepts array or a string, you have to write an if condition inside the method body. And with each if condition, there's more combinations, more states to test. So you are actually adding more work for yourself. And actually, you can't write a native type hint for the union type. You again have to add it to the PHP doc. So again, that's a no. But instead, I would like to recommend you to separate the method into one which accepts the arrays and the other one which accepts strings. So this supports the single responsibility principle, because you write methods that do one thing and they do it well. And the user just calls the right method based on which type they possess in their hand or in their variable. And this approach represents elimination of branches. It's less code, and it's less code to test, and less things to go wrong. And you should also apply the same principles to return type hints, because you should always return one single type, and that also simplifies things. Okay, next, a little bit more tricky situation. So let's say we have a method which accepts a date range like this. We are setting validity of some entity, and we are accepting from and to. So What if the user wants to remove these dates from an entity? The first solution that comes to mind is to make those parameters nullable. But again, there's a problem with that. Because usually, when I see multiple nullable parameters at once, it means that only some nullable combinations are valid. So actually, only the first two lines are intended usage of the method, which isn't obvious from the method signature. So the bulletproof code would prevent the last two calls to ever happen, but it's not possible with this kind of signature, because we can just call the method in an invalid way. And it means that with this kind of signature, we have to write if branches, and we will probably throw some exception from inside the method body. And the better solution is to separate those methods in two, because multiple nullable parameters usually mean that the same method handles multiple use cases. So in this case, it handles setting the validity and also removing the validity. So if you have multiple nullable parameters, you should try really hard to try to name those use cases and separate them into multiple methods. So one method will have all the parameters required, and the other method will won't accept any parameters at all, or it will accept parameters for its use cases, and it will also be required. So now everything can be read from the method signature, and no additional runtime check is required, and the static analyzer is also able to reason about this code, because it can read everything from the method signature. Okay. I would like to discourage you from writing dynamic code like this. So no $$ variable, no dynamic accessing properties binary names like this, no new $$ class, because static analysis and also your developers cannot recognize what this code does and what it returns. So when you are calling dynamic methods like this, you are risking that you won't pass required arguments for the method. So that creates a problem, and you will find out about it in the runtime. Next, callables. When some method expects a callable, you have multiple options what you can pass there. You can pass a string, you can pass an array like this, you can pass a class that has the invoke magic method, or you can pass an anonymous function. But with arrays and strings, it's really hard for IDEs to find these occurrences when, for example, renaming a function or renaming a method, because you are writing strings with some magic, you are writing strings that mean something else than just the string. So it's really hard to find those by the IDE. So and also other reason not to pass functions directly like this is because it might lead to unexpected results. So this is an example from JavaScript, and it doesn't return 1, 2, 3. It returns 1 and 2 not numbers, because the parse int accepts base of the number. That means like decimal or hexadecimal or binary, and as the second argument. And the map function passes actually the index of an element as the second argument. So the result is this, because the function calls look like this. So when you write an anonymous function, you have to explicitly pass all those arguments that you intend to, and you are also not risking weird behavior like that. So also with anonymous functions, you are actually writing PHP code instead of some magic strings. So those calls can be found by an IDE, and explicit argument passing leads to avoiding unexpected behavior. loose comparisons lead to a lot of unexpected mistakes. So who is comparing in their application using 2 equal signs? And who is using 3 equal signs? Okay, cool. I'm really glad. Well, I circled the weirdest results. So empty array equals null. Why? Empty string equals 0, or string with 0 equals false. That's really weird. So this is actually how it should look like, because the result using strict comparisons is much more predictable. But you cannot, when comparing objects, 3 equal signs actually require the objects to be of the same instance. So it's not usable, for example, for datetimes. But I don't recommend comparing datetimes using comparison operators, because it's probably more precise than you need. So PHP 7.1 introduced milliseconds for datetime objects, and that broke a lot of code and a lot of tests. So for datetimes, I rather recommend comparing using strings from the formal method, or you can, for example, compare using timestamps. Okay. For the same reason, you should also avoid using empty, because it's also too loose to be practical, and it's unusable for validation. So why is the string with a 0 empty string in this case? You should always use more specific comparison, like a count function on an array, or a strict comparison of a string against an empty string. phpstan-strict-rules is a complementary extension package for phpstan, and it's for strict and strongly typed code with no loose casting. So it brings you additional safety with defensive programming. So this package requires you to use only booleans in conditions. So it disallows you to use some loose casting of other types, the booleans. So you can just write if some string, but you actually have to compare the string to something, so that it results in a boolean. And the other rules are in a similar vein. For example, using third parameter true for the inArray function also does strict comparisons for you. Okay, I have a small refactoring tip for you. If you are changing a return type of a function or method, you should first rename the function or method. And you should do it manually, because it will force you to go to the places where the method is used, and it forces you to fix them. And for example, when a method starts returning an array instead of a single value, when renaming it, it forces you to go through the code and exchange all the code for some for each or some selecting from the array. Okay, so those were local tips for your code, and now we will go through structural tips that are about the whole application. So who has ever written code that looked like this? And who writes code like that today? No one. Good. So it's obvious that you should move everything to classes, so it's obvious where each variable comes from. And no code should be in global scope. It should be all in functions and classes and methods. This is a diagram how the types should flow through your application. The first step will unfortunately be always weakly typed, because that's the nature of HTTP. Everything in an HTTP request is a string in the post body and in URL parameters. And the role of your controller, if you use MVC, is to validate everything and to create objects from incoming data before sending them further down to your model. And everything from controller forward is strongly typed. It's in nice objects, and you can verify statically that the rest of your application works. And if you let types spread out to your application, it makes it much more reliable, and everything is checked and type solid. Okay. Well, not all code is created equal with regards to importance and also probability of a bug. And I differentiate between business logic and wiring. So wiring is what actually is holding an application together. It's a glue between its layers. And I suspect that more than 50% of code in a modern application, modern code base, is wiring. And the more complex your architecture is and bigger application you got, the more layers and wiring you will need. But wiring is not useless. It enables reusability, clarity, testability, and maintenance. And thanks to wiring, we can, for example, extract common pieces of code and call them from multiple places. On the other hand, business logic is completely different from wiring. Business logic is what we are paid to do. It's the main goal of our application. And so business logic is, for example, value validation, arithmetic operations, routing, filtering, parsing, everything interesting that your application does. So you probably guessed that I recommend testing business logic thoroughly with your unit tests. And wiring does not need unit test much because the static analysis is sufficient there. So you don't have to write tests for your getters and setters and assigning to properties because phpstan can tell you if you made a typo or you are assigning a wrong type, etc. Well, some bugs can find their way into wiring and they can be detected by static analysis. So if some values are interchangeable because of the same type, phpstan cannot find this error. But this kind of error is really rare and it's not economic to write tests for getters and setters just because of these situations. Because it becomes even more rare when you write more and more specific objects, so they are not interchangeable anymore. Okay, so what is unit test? What criteria has to a test meet in order to call itself a unit test? So obviously, unit test is executed PHP code directly and only in memory. Unit test does not connect to the database, it does not access the file system, it does not make network calls, and it doesn't need a DE container. So unit test is in kind of a quarantine, and you just can't touch anything else besides what you have available in your PHP code. And I really like unit tests because they are fast and they provide accurate localization of a bug. Because when your unit test fails, it's a unit test of a specific class, of a specific method. And if that unit test fails, that you know exactly where your problem is. And also in unit tests, you don't have any problem with your test speed, so that you are able to check very often that you didn't break anything, because you can run them very often. And so from all kinds of tests like integration, functional, Selenium, the majority of them should be unit tests in my opinion. So the common mistake people do when they are writing code is that they are interweaving fetching data with business logic. So in this code, you can't do anything else but mock. You have to mock because if you want to test your business logic that is inside this method, you have to provide that data with it, and the data come from the repository. And if you don't want to touch the database, you have to mock so you can pass the data to your business logic. Also, with mocks, it's white box testing. That means that when you are testing, you can see the implementation and you are writing the test against the implementation. Because when you are configuring the mock, you actually need to see what is called on the mock and in which order, etc. So I don't recommend putting data fetching and business logic into a single class. Because even when you have your SQL queries in a repository, the business logic layer shouldn't call the repository. It should have the data passed to it. So the correct architecture, in my opinion, should look like this. You should extract the business logic so that it gets all the data it needs on the input as method parameters, and the business logic should return an object with the result. It shouldn't have any side effect. That means that you don't have any reason to mock anymore, because you pass simple, small value objects on the input, and those value objects should be easy to create. So if I'm mocking with this code structure, I'm doing something wrong somewhere. Probably I have too large objects that are hard to create, and I'm doing something wrong, definitely. And actually, the business logic is the only thing that I would recommend unit testing here. Nothing else needs unit tests. So this is how the facade looks like. The calculator represents our business logic service, and we are delegating the calculation to it. And the calculator, because it just has data on the input and passes something back as the output, it's very easily unit testable, and you don't need to mock anything with it. This is typically how such unit test for a business class looks like. We can make use of a data provider, and we can really simply, really fast test many combinations to test the business logic really thoroughly. And it's very easy to add another test like this. Well, this is funny, but I actually don't find this true. Because if I unit test two classes that are meant to work together, from my experience, I don't have to write integration test for them. Because the fact that the result of the first class can be passed as an input to the second one is checked by phpstan, thanks to the types compatibility. And because I don't use mocks, it also makes me confident that the code works more. But I don't discourage you from using integration tests. They have their place, for example, when you are testing communication with some external systems, with some third-party APIs, if those systems have a test API that you can call very often. The approach that I just introduced to you requires to use an ORM like Doctrine. So who uses object relational mappers? Why do I use it? Because when someone uses an ORM, it might be because of some wrong reason. There are many wrong reasons to use an ORM. One reason like that might be that you are too lazy to write an SQL query, because Doctrine will generate an ineffective SQL queries for you because it has to guess what you want. So I'm using an ORM, and at the same time I'm writing SQL queries or DQL queries to be more precise. And another wrong reason to use ORM is because you just want the option to switch a database engine, and whoever successfully did that, to switch a database engine of legacy application. Not a lot of people. So that's also a wrong reason, but the right reason to use an ORM is so I can represent database and I can manipulate database data in an application with objects and modify them consistently. So that's the reason why I use an ORM, and I really like it, and I'm not asking it to do the job that does badly, but I'm asking it to do one simple job to represent data as objects. Okay, so I wrote an article about this topic in April issue of PHP Architect, and it's actually available for free online. So if you want to read more about this topic or just remember what I said here, you can just read the article online. So definitely take a look at it. Okay, so that's all from me today. Thank you.